In this video, we'll look at a contextual situation and application problem where we will use factoring to solve an equation. The context here is that the height in feet of a water balloon t seconds after it was launched from a water balloon slingshot is given by the formula h equals negative 16t squared plus 96t. Part A asks, what is the height of the water balloon 2.1 seconds after it was launched? To answer this question, we first have to recognize that 2.1 seconds is a time value, so that's telling us a t value. In this particular situation, it's 2.1 seconds after launch, telling us our t value is 2.1. So what we're going to do is substitute 2.1 in for the t's in the formula and see what the h value is, since that's the question. What is the height? So h will equal negative 16 times the quantity 2.1 squared plus 96 times the quantity 2.1. Remembering our order of operations, we need to square the 2.1 first. Putting that into my calculator, 2.1 squared is 4.41. Now that we've taken care of the exponents, we'll now deal with the multiplication. Negative 16 times 4.41 is a negative 70.56. 96 times 2.1 is a positive 201.6. And to finish off, we will do the addition. A negative 70.56 plus 201.6 gives us 131.04. Again, we want to recognize that the t values, the time values, are measured in seconds, while the height is measured in feet. So the value here that we have found is a height value, so it should be measured in feet. To answer the question, what is the height of the water balloon 2.1 seconds after it was launched? Our answer will be 2.1 seconds after it was launched. The height of the water balloon is 131.04 feet. In part B, we want to know when the water balloon will hit the ground. It's important to recognize from the beginning, a when question is saying, what is the t value? What is the time? If we're being asked about the time, we have to be given the height. The only other information we are given is that the balloon hits the ground. Well, in the formula we know h represents the height of the water balloon, and when the water balloon hits the ground, well, its height's going to be 0. So to answer this question, we need to put 0 in for the h and find the t value. Putting 0 in for h, we will have 0 equals negative 16t squared plus 96t. Unlike part A, where we were evaluating, here we actually are solving an equation. To solve this equation, we're going to go to the usual process, the greatest common factor. In this equation, the greatest common factor for negative 16t squared and 96t is going to be a negative 16t. So if we factor negative 16t off of both of those two terms, we'll be left with t minus 6. At this point, we do now have this polynomial factored. So for this equation to be true, either negative 16t has to be 0, or t plus 6 has to be 0. So we'll set each of those equal to 0 individually. Negative 16t equals 0, or t minus 6 equals 0. To solve negative 16t equals 0, we can divide both sides by negative 16, giving us a t value of 0. To solve t minus 6 equals 0, we'll add 6 to both sides and obtain t equals 6. This equation does have two solutions, so what we want to think about is if both of them make sense in the context, and which one actually answers the question. Knowing that the t is representing how many seconds after launch, a time value of 0 is really telling us when it was launched. So t equal to 0 is really telling us the balloon was launched from the ground. While that is a reasonable statement and it does make sense in the context, it doesn't answer the question when the balloon hit the ground. So that brings us to our other possibility, t equal to 6. T equal to 6 would mean 6 seconds after launch. That also makes sense in the context. 6 seconds after it was launched, it definitely could have hit the ground, and so that will be the answer to our question. We'll answer the question in a complete sentence. When will the water balloon hit the ground? The water balloon will hit the ground 6 seconds after launch. Part C, the final part to this question, when will the water balloon be 144 feet above the ground? Again, recognizing that we're asked a when question, we're needing to find a time value, we have to be given a height value. Well, we've just been told the water balloon is going to be 144 feet above the ground, so that is a height value. So to answer this question, we'll substitute 144 in for the h and find the t values. Substituting that 144 in for h, we get 144 equals negative 16t squared plus 96t. To solve this equation by factoring, we need to set the equation equal to 0. We have two ways we can do this. We could subtract 144 from both sides, or we could bring the two terms on the right side over to the left. My usual method is to try to avoid having a negative leading coefficient, and so for that reason, I'm going to bring the negative 16t squared and the positive 96t that are on the right over to the left side. To do this, I'm actually going to add 16t squared to both sides of the equation. I will subtract 96t from both sides, and we'll still have that plus 144 on the left side of the equation. So setting this equal to 0 and keeping the leading coefficient positive, we'll have 16t squared minus 96t plus 144 equals 0. At first look, this might seem like a pretty challenging or a pretty messy equation to solve, but again, always look for a greatest common factor. We know from part B that 16 divides into 16 and 16 divides into 96. 16 also divides into 144, so the greatest common factor here is the best thing it could have been. We can factor the 16 off of the rest of the polynomial, leaving us with, in parentheses, t squared minus 6t plus 9. So our new equation is 16 times a quantity, t squared minus 6t plus 9 equals 0. We now need to recognize we have a trinomial remaining in parentheses. Not only is it a trinomial, again it is a trinomial with a equal to 1, so I'll turn my attention to the c value. The c value is 9. I need to ask myself, what multiplies to make 9 and adds to make negative 6? Well, I know negative 3 times negative 3 is 9, and I know negative 3 plus negative 3 is 6. So the two factors I needed are negative 3 and negative 3, so we can rewrite this t squared minus 6t plus 9 as t minus 3 times t minus 3. So our factored version of this entire equation is now 16 times the quantity t minus 3 times the quantity t minus 3. Again, we have three things that multiply to make 0, which tells us one of those three has to be 0. Since 16 is a number and 16 does not equal 0, we don't have to worry about that being the factor that's equal to 0. So instead, it's either that t minus 3 equals 0 or t minus 3 equals 0. Now, normally we wouldn't write both of those down. As long as you solve one of them, you're really solving both of them. So to solve one of those, t minus 3 equals 0, we'll add 3 to both sides of the equation, and we'll get t equals 3. Since the other possibility is the exact same thing, we don't need to write that down. So we now have the time value for when the water balloon will be 144 feet above the ground. We just need to answer the question. When will the water balloon be 144 feet above the ground? So our answer, the water balloon will be 144 feet above the ground 3 seconds after it was launched.